Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at introduction to electrolysis. Electrolysis is the decomposition of an electrolyte by the passage of electric current through it. It can also be defined as the use of electrical energy to drive chemical reactions, or the use of electricity to bring about redox reactions. What we have on the board here is an electrolytic cell. We're going to be looking at the components. In this electrolytic cell that is illustrated on the board here, we can see the metallic conductors, that is the anode and the cathode. The anode is the positive electrode and the cathode is the negative electrode. These electrodes are connected to a battery through wires. And then here we have an electrolytic conductor, which is also called an electrolyte. On the passage of electric current, the electrolyte decomposes, that is, splits into positive ions called cations and negative ions called anions. The positive ions called cations migrate towards the cathode. The negative ions called anions migrate towards the anode. During electrolysis, several types of ions may be present. However, it is only one type of cation and only one type of anion that will be discharged at the cathode and the anode, respectively. Now, this means that the ions that will be discharged at the electrodes depend on certain factors. These factors are collectively referred to as the principles of preferential discharge of ions, and there are three of them. The first is the position of the ion in the electrochemical series. The second is the concentration of the ion, and the third is the nature of the electrode. So we're going to look at them one after the other. The position of the ion in the electrochemical series determines which of the ions will be deposited at a particular electrode. For instance, if there are two types of cations in an electrolytic solution, for example, potassium ion and copper 2 ions, these are the two types of cations that are present. For instance, copper 2 ions is going to be preferentially discharged to potassium ions. The reason? Because copper 2 ions is lower in the electrochemical series than potassium ions. It is also possible that an ion that is lower in the electrochemical series is not discharged preferentially. This means it is possible for an ion that is higher in the electrochemical series to be preferentially discharged to the one that is lower. And this is where concentration comes in. For example, in the electrolysis of conc NECO, that is the electrolysis of brine, there are two types of anions present. Cl-, that is chloride ion, and OH- ions, that is hydroxide ions, which comes from water. In the electrolysis of conc NECO, OH-, which is lower in the electrochemical series, is not discharged in preference to chloride ion. Instead, chloride ion is discharged in preference to hydroxide ion. And the reason for this is because the concentration of chloride ion is more than that of hydroxide ion. The nature of electrode can also influence or determine the ion that will be preferentially discharged at an electrode. There are two types of electrodes in electrolysis. We have inert electrodes and we have active electrodes. Inert electrodes are electrodes that do not influence the ions that will be discharged or deposited at the electrodes. Examples of inert electrodes are platinum electrodes and electrodes made of graphite. Active electrodes, on the other hand, influence the ions that will be deposited. Examples of active electrodes are electrodes that are made of copper, silver, mercury. Now let us explain this using some examples. In the electrolysis of aqueous NECO, using mercury as the cathode, for instance, what happens? In the electrolysis of NECO, aqueous NECO, using mercury as the cathode, there are two types of cations in solution. Sodium ion and there is hydrogen ion from water. Ordinarily, hydrogen ion is supposed to be deposited in preference to sodium ion because it is lower in the electrochemical series. But this does not happen. Instead, sodium ion is deposited in preference to hydrogen ion. And the reason is because sodium has a strong affinity or likeness for mercury. So because of the affinity between mercury and sodium, the equation at the cathode is going to be sodium ion undergoing reduction that accepts an electron to give sodium atom. So which means that sodium ion is going to be deposited at the cathode. And not just that, the sodium ion is going to react with the mercury cathode to form sodium amalgam. Now, this is an example of how the nature of the cathode influences what is deposited during electrolysis. Another example involving the anode, which we can look at, is in the electrolysis of aqueous CuSO4. The electrolysis of aqueous CuSO4 using copper as the anode. In the electrolysis of aqueous CuSO4 using copper as the anode, there are two types of anions. You have sulfate ion as well as hydroxide ion. The hydroxide ion is from water because in electrolysis of an aqueous solution, water which is present also splits into hydrogen ion and hydroxide ion. So the hydroxide ion here is from water. Now in this particular electrolysis, neither hydroxide ion nor sulfate ion is deposited at the anode. None of them is deposited at the copper anode. Instead, what happens is that the copper atoms on the anode will ionize and go into solution as copper ions. So what happens at the anode is that the copper atoms will lose electrons and ionize, becoming copper 2 ions and go into the electrolytic solution. And when they go into the electrolytic solution as copper 2 ions, they will migrate to the cathode And when they get to the cathode, the equation of the cathode is that the copper 2 ions will undergo reduction by accepting 2 electrons and be deposited as copper. So what this means is that in the electrolysis of aqueous copper 2 tetraoxosulfate 6 using copper as the anode, neither hydroxide ion nor sulfate ions is deposited at the anode. Instead, the copper atoms on the anode are transferred from the anode to the cathode. And this happens by the ionization of the copper ions in solution of Cu2+, and then the discharge of these copper 2 ions as copper at the cathode. So copper ionizes by losing 2 electrons and becomes copper 2 ions in the solution, and these copper 2 ions will migrate to the cathode, undergo reduction, and be deposited as what? Copper. So essentially what happens is that in the electrolysis of aqueous copper tetraoxosulfate 6, copper 2 tetraoxosulfate 6, what happens is copper is transferred from the anode to the cathode. And this particular electrolysis is actually used in the purification, or you can say in the electro-refining of copper. So, these 2 examples, electrolysis of aqueous NaCl using mercury as the cathode, and the electrolysis of aqueous CuSO4 using copper as the anode, are 2 examples that show us that the nature of the electrode influences what is deposited during electrolysis. Thank you very much for watching. See you next video.